This is Cycle 2, Week 13 Science. We're going to be doing 2 experiments today. The first one is number 161, spoon bell. And the supplies for this one is going to be a metal spoon with kite string tied around it. I will be supplying the kite string, the slinky, the rubber band box, a picture of surface waves on the ocean, and an activity that's called string telephone. What you need to bring from home is 8 to 10 metal spoons for your class because every kid is going to be using one and I don't have 40 at home. So just the metal spoons, that will be your requirement. And we're going to start by reviewing the scientific method, and then we're going to tell them we're going to be learning about sound, vibrations, and something called friction. So the purpose of this experiment is to determine what makes a sound loud or what makes a sound soft. And the question that they might have is, what is sound? So then we're going to talk about sound waves. And there are many sound waves, but we're going to be talking specifically about 3. The first one is transverse, and we're going to be using the slinky to show what a transverse wave is. So in your classroom, you can either have a mom be your anchor, or you can attach your slinky onto something, like a handle or whatever you can find. And the slinky is only for demonstration by the tutor. It's not going to be for the kids at all. So you're going to stand back, and for transverse waves, they run perpendicular to the direction that the wave is moving. Okay, so it's going to, you're going to kind of stand out, and you're going to do a traditional wave motion like this, and it's running perpendicular to where the energy is moving, and that's what a wave looks like. Then you're going to keep it anchored wherever you have it, and you're going to bunch it up. The next one is a longitudinal wave, and this one is opposite. It runs parallel to the direction of the wave. And so you're going to bunch it up, and then you're going to let it go. And so what they're going to see is that it's moving straight across, almost parallel to the ground. Thank you. And then the third wave we're going to talk about are surface waves, and those are on top of the ocean. And I have a picture to show here. We're going to next introduce the concept of vibration, and that's when we're going to use this box with the rubber band. And you're going to kind of strike it like that. You can even have the kids kind of go around and feel it as you strike the rubber band like this. And you're going to ask them, do you see how it moves? This is what the vibration looks like. Then you're going to have them put their hands over their voice box and sing la 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 and ask, do you feel a buzzing sensation in your fingers? That's what vibrations feel like, and vibrations are what make sound waves. The last one you're going to introduce is amplitude. And amplitude is how loud or soft a sound is, and the wave is bigger when the sound is louder and smaller when the sound is softer. And we have a picture on Nicole Liam's printout that I don't have yet that you can show the kids. So the experiment is to take, every kid's going to get a metal spoon and a string. They're going to wrap it twice on this side around their left index finger, twice around their right index finger, and then everybody is going to stand at the edge of the table. Okay? And they're going to lean over, and at first they're just going to stand like this, and they're going to strike the table gently. Maybe even more gently than that. So it's barely going to make a sound. Okay? The next time they're going to do it, they're going to take these and they're going to plug their ears. And then they're going to hit it. And it sounds a lot different. It completely sounds like a church bell when you plug your ears. Then the last time they're going to do it, they're going to plug the ears again, but they're going to hit it harder. Okay, so the last 2 sound like church bells, one soft, one loud. The first one doesn't really sound like much of anything, more like a ting. In your conclusion, you can talk about The harder we tapped the spoon, the louder the sound, and we can talk about what the amplitude would look like on those waves. Last for this experiment is the string telephone. So your kids will pair up. One will talk into this one, la 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 la. The other one will stand over here and listen as the other person talks. And the main thing you need to know is they need to keep the string tight. If it's not taut, the vibrations aren't really gonna work and it's just not gonna work. So make sure they know to keep it tight and have them practice doing one talking, one listening, and the explanation is in here that the vibrations go into the cup from your voice, down through and into the string. And you can hear surprisingly far if it's done right. All right, now we're gonna move on to the next one, and that's number 162, humming glass. The props or the supplies you will need for that are a stemmed glass, a cup of soapy water. Your dish soap for this is in your science bin. This small one has vinegar in it. I will have the vinegar and I will put it in your bowls in the morning. And then a cup of just clean, non-soapy water. And then I also am gonna provide a towel for you because you're gonna have to rinse this and it's gonna be dripping everywhere. So in this one we're gonna learn how vibrations are made by friction. So we need to talk about what friction is. See if any of your kids know. If they don't, I have an explanation here. Excuse me. And you're gonna start by talking about your materials, and then you're gonna tap this, and you're gonna say, notice the sound that the glass makes when I tap it with my finger. We're going to use the idea that sound can be produced by friction to try to make this glass sing for us. I just made my glass sing when I tapped it, but is tapping an act of friction? No. Friction is that resistance that we're gonna get. So, how many of you think I can use friction to get this glass to sing for us? You can see what their hypothesis is. So first, you're gonna rub your finger around the glass. And when you do that, you notice it doesn't make any noise. That didn't work at all. But you can tell them it's because there's oil acting as a lubricant on your finger. And we use oils for all sorts of things, like frying our eggs and putting in our engines in our cars to help them run. So, in order to get friction on this glass, I'm gonna need to wash the oils off my fingers. So I'm gonna dip it in the soapy water first, and I'm not gonna dry it. And I'm gonna try it. It's still not making a sound. And that's because I still have oil from the soap now on my finger. So what I'm gonna need to do is I'm gonna need to rinse my finger off of the soap, and I'm gonna need to clean the top of the rim from the oils that I already got on there from my finger. So friction doesn't slip and slide like a soapy finger. It catches. All right. And of course it's not working.
You need the vinegar?
Oh right, I forgot the vinegar. Thank you. So now I'm really gonna clean my finger by sticking it in the vinegar. There we go. What would I do without you, Holly?
Mm-hmm.
You guys see that?
Mm-hmm.
All right, it finally made a sound. So if you still have time, each of the students can do this. They can wash it off, dip it in vinegar, have it make a sound. And after the conclusion, after talking about that, you're done.